Happy Friday. Welcome to Science Class Lesson 2. Today we're going to talk about what are the effects of the movements of the Earth and the Moon. So we spent a few days talking about what the Sun is and then what the Moon was. And today we're going to talk about the different seasons and the things that we have with rotations, revolutions, tilt. Awesome stuff. You got your worksheet ready to go to fill in the notes from these 2 pages today. Our summary statement says days, years, and seasons are caused by Earth's rotations, revolutions, and the tilt. So days by rotations, revolution is what a year is, seasons by the tilt. The changing position of the sun, moon, and the Earth can cause solar and lunar eclipses. We'll get that next week, guys, when we finish up this lesson. Earth on its axis. It says, think about a time thousands of years ago, before telescopes had been invented and before astronauts had ever traveled into space. What did people think of Earth and its sun? If you look at the daytime sky, the sun rises in the east and it sets in the west. Boom. Number 1 on your notes. People naturally thought the sun was moving around the Earth. This was geocentric, guys. Okay, now let's fill in the rest of your notes. Why does it say it rises in the east and sets in the west? This happens because the Earth is spinning counterclockwise. You're going to want that for your test. It says that down here also, and I'll stress it again, but that's a counterclockwise spin. We now know that the sun is the center of our solar system and that Earth and other planets revolve around the sun. Earth also rotates on its axis, an imaginary line between its poles. Okay, so we just got number 2 in your notes. A day is the total time for a planet to make one complete rotation. The sun seems to revolve around the Earth because of Earth's rotation. Okay, so guys, looks like the sun is moving. That's because of a spin of the Earth. The sun's not moving, we're spinning around it, and we're revolving around it. It's kind of amazing when you think about it. It says to understand Earth's rotation, picture Earth spinning on a pole. The speed here, which would be the biggest circle at your equator, we're cruising at 1,670 kilometers per hour. Now, I know that's kilometers, guys, but that's still over 1,000 miles per hour. So the sun seems to rise and set faster at the equator because the speed is going faster. If you wake up early in the morning, you might see the sun just beginning to rise above the eastern horizon. The sun always seems to rise in the east because Earth spins from west to east. That's that counterclockwise motion we're talking about. Because you spin along with Earth, the sun is the first visible in the east. You experience daytime as long as the sun is visible from your location on Earth. So when we talk about daylight hours, guys, we're talking from the time I can see the tip of the sun to the time I can't see the tip anymore. Daytime ends as soon as the Earth has turned enough that the sun seems to be setting in the west. Everything else would be nighttime. Nighttime is when the sun is no longer visible to you. Okay, so they have this. In the evening, the sun appears to sink below the western horizon. So as I'm looking at the path of the sun rises in the east. Sunlight begins to warm up my Earth. The heat from the sun is most intense as soon as you get to noon and it's straight over your head. And then it starts to set in the west, and then at midnight, the side of the Earth opposite would be experiencing noon. So the sun is always shining, guys. It's just on the opposite side of the Earth. Okay, when you wake up on a winter morning, though, it can still be dark outside. You and I definitely experience that, don't we? In the middle of the winter, it's like it's barely light by the time you get to school, and it's almost getting dark when you leave school. We have very little sunlight. If you wake up at that same time, so let's say school at 7:30. In the winter, it's barely getting light. In the summer, it's been light for a couple of hours. We are starting to experience that now, and the days keep getting longer. The number of hours of daylight changes throughout the year. Notice on the globe how Earth is tilted on its axis. One half of Earth is usually tilted toward the sun. That side has more daylight hours and fewer nighttime hours. The other half of the Earth has fewer daylight hours and more nighttime hours. So when we're tilted toward it, it's summertime, we got more daylight. When we're tilted away from it, so if the sun would be over here, we would in the northern hemisphere be tilted away, that would be winter. More night, less day. The tilt on Earth's axis has an even greater effect the farther you get to the poles. So the farther we tip away, guys. So you think about Wisconsin. Now I know we're looking at Africa here, but Wisconsin would be about right there level. The farther I get up here, the more extreme it is, or the farther down here, the more extreme it is. In fact, it says this. When the northern part of Earth is tilted toward the sun never fully sets at the North Pole. Every state has a nickname, like Wisconsin is known as the Dairy State. Alaska is known as the state of the midnight sun. You should write that down for extra credit. Alaska, midnight sun. In other words, in Alaska, far enough north, you can literally see the sun at midnight. The same is true at the South Pole. When it is tilted toward the sun, daylight and darkness at the poles each last 6 months. Guys, I just want you to be careful with that I don't want you to think that for 6 months it's always light, and then for the next 6 months it's always dark. No, it slowly changes just like we slowly change, but it literally changes major extremes because of the distance of it. You may have noticed that the moon is sometimes visible during the day. The moon can be seen whenever it is on your side of the earth. This is sometimes during the day and sometimes during the night. And we'll talk more about the revolutions of the moon as we continue to work our way in the last part of this lesson with solar and lunar eclipse. Now let's just appreciate the size a little bit of this as we finish up our notes here for today. It says comparing your size, they have a little piece of the sun, they have the moon, and they have the earth. If you stand on top of a mountain or on an ocean shore and look toward the horizon, you realize that Earth is unbelievably large. Compared to the sun, however, Earth is just a dot in space. The sun is more than 200 times wider than the Earth. So if we would hollow out the sun, we could fill it with more than 1 million Earths, guys. So if we wanted the volume of a sphere, we haven't learned that in math class yet, but you're going to learn that is 4/3 times pi times radius cubed. And so we have a radius that is literally 200 times wider than us, so you can fit more than 1 million Earths inside it. The mass of the sun is 330,000 times the mass of Earth. Therefore, it has a gravitational pull 300 times that of Earth. So if you weighed 100 pounds on Earth, you weigh 3,000 pounds on the sun. Isn't that amazing when you start to think about what gravity can do? The difference between the Earth and the moon are not quite as crazy. Earth is about 4 times as wide as the moon, so about 50 moons could fit inside a hollow Earth. The mass is about 80 times the mass of the moon, which makes the gravitational pull of Earth about 6 times stronger than the moon. That's why an object that weighs 60 newtons on Earth would only weigh 10 on the moon. So you divide by 6 when you go to the moon, you times it by 30 when you go to the sun. All right, guys, we got just a start today talking about all the awesome things that is our Earth, our sun, and our moon, and comparing some of the sizes, and then understanding today how the spin of the Earth gives us the amount of daylight hours. We'll talk more about that on Monday. Have a great day.